Cameron Yick is a senior software engineer developing interactive data visualizations and diagrams at Datadog. You can read more about his work on our announcement of this Meetup event. There are several things that impress me about Cameron. Work-wise, I'm always impressed by the questions he asks at our event. He somehow manages to handle all the details of hosting the event, answering questions while still absorbing enough to ask the most insightful questions. I'm even more impressed by his activities out of work. I'll give just one example. When vaccines for COVID first came out and seniors were spending all their time trying to find a place to get vaccinated, Cameron wrote an app where you gave your address and it let you know if the places near you had available appointments. This app was updated regularly. Spending one's spare time on activities like this says a lot about his character. The New York Meetup considers itself very lucky to have Cameron as a member. Cameron, it's all yours.
Naomi, thank you so much for the very kind introduction. And thank you everybody for joining us in exploring the code click gap today. I've been attending this meetup for a little bit over 5 years now. And I've been looking forward to having something to give back ever since I started. So if I seem a little bit in awe, that is why. To get us started, Randy, if you can activate the short quiz, I just want to get a sense of what our audience is like in terms of where people's preferences are. Whether you find yourself using a click-based tool or a coding-based tool in your work. We'll leave the quiz open to give people some time to respond, and I'll carry on with my introduction. So today's talk is about bridges, partly because I have loved how this meetup, actually the whole field of DataViz, builds bridges between disciplines, from artists to scientists to business people to journalists and everyone in between. About 8 years ago, I started my coding journey because there was a gap between the visualizations I could imagine and the visualizations I knew how to make. And I wanted to code so that I could get my ideas into a form where others could see them and critique them and eventually use them. And it seemed like learning to code was the one path forward. Along the way, I had many moments of doubt about whether that delay would be worth it. My goal today is to show some approaches that will let anyone close that gap for themselves and to recognize that you don't have to cross the chasm at the widest part just to be able to make novel and useful data graphics. Is the poll?
Yep. Okay, so we've got about 85% participation, so I'm going to end it and let everybody see the results.
Cool. So for anyone on the recording, the split is 60, 26, 14, with applications leading the way, but also a good 40% of people are at least coding in some capacity. So cool. All right. These numbers will come back later. Before we get into the main content, I want to take a moment to give a shout out to my team at Datadog. Many of the ideas that we'll see are reflected in our conversations, in our brown bags, and our hackathons, including people who I didn't have space to fit. I joined Datadog as the 5th member of the DataViz team. And as you can see, we have a few more than that. If you would like to fill in this additional square, we would love to hear from you after the event. Oops, the circle. All right. But for those who haven't met, my name is Cameron. At Datadog, I work on visual analytics tools that help people monitor and care for their computers in the cloud. Outside of work, as Naomi mentioned, I help out with the DataViz meetup, and I also like to participate in Open Data Week in New York. To me, these two things are very related because I'm drawn to spaces with ideas that lack a single physical representation. And that's exciting to me because I think that means you get to choose how to turn the abstract into the tangible. I'm going to show you two examples. work that reflects that. So I used to take the train every day. I would take a look at the Metro North. This is half of the schedule. And it was very busy, but I thought that was all there is. I didn't really know how busy the tracks were until I connected two dots. The first of these dots was being introduced to this book, which this is a graphical representation of the train schedule in France in the 1800s. And one day I learned that there is a CSV of this same data available for the Metro North in New York. So I combined those two ideas and made a graphical train schedule based on the design by Charles Ibri. And there's a lot of nice blog posts online about where you can learn the full history of this. One other example, there's a book I'm sure many of you may be familiar with about visualizing personal data. And I thought this idea was really exciting, breaking free from conventional chart forms, and I thought it could be really engaging. So I took this idea and I applied it to making thank you cards for people on my team as their internships wrap up. So this is a representation of some GitHub data. And the intern gets to guess which project they worked on. So this is 4 projects, and you can sort of guess which things had steady contribution versus what is spread out. On the right, for those not working in GitHub, many people work with a project management software like Trello or Jira. So we have a similar deal going on here. I wish that I could have used some of the tools that you're going to see today to clean the data instead of doing it from scratch. But if you're interested in doing this sort of thing for your team, I would love to hear about your ideas afterwards. Cool. So with that, these were fun projects, but for me, the code click gap has a little bit more serious origin story. It cuts back to both why I started programming and why I wanted to visualize data. Hopefully it's not a relatable story for you, but for me, it's a story of lost work. When I first learned to graph, I thought of it as a thing that you do at the very end of a presentation when you need something for a slideshow. Then I had what I now call the case of the stretchy brains. So situation is this: I was in a lab studying youths with ADHD, and given a set of brain scans and behavioral test results, we wanted to represent what the brain of someone with ADHD might look like. The data comes in voxels. You can think of that as a 4-dimensional cube. So each pixel is in 3D space and it changes over time. And in order to compare these volumes of voxels, you have to reduce 4 dimensions down to 2 dimensions. And the problem was it took me 3 weeks to figure out how to do that. And it was only after 3 weeks we realized that in order to compare the brains, we had to use an algorithm that was developed for adults, and it doesn't work for children's brains. Now, most people, including myself, cannot picture 4 dimensions, so it didn't really seem like there was a way around this. Looking back, I feel that if I had tools that let me work with high-dimensional data sooner, that didn't involve so much work, we might have been able to change the project earlier and rescue the project. But as it stands, this experience imprinted me with the idea that visualization is very core to problem solving and not just something you do for presenting at the end, even though that part is important too. So this story came back to me just about a year ago. Professor Ravi Chu at U Chicago asked a question to a group of computer scientists at the International Functional Programming Conference. And he asked, when you have a choice between using a click-based tool like Photoshop or Word, also called a GUI sometimes for graphical user interface, or you can use a programming language like processing or D3, how do you decide which one to use? And there are 2 common constraints that come up, even for people who have a choice between multiple tools. People are busy and people are picky. Nobody has enough time. So put differently, people are limited by time and expressiveness. You don't want to get stuck with a tool that isn't flexible enough, but sometimes we're willing to give up some flexibility in exchange for getting an approximate result sooner, if that gives you a sense of whether this line of inquiry is worth continuing. So clicking in a GUI, I think of as a low floor tool. That means you can get started quickly, but you'll be limited by whatever options are pre-considered as important to make available to you. On the other side, coding has a high ceiling. It'll take you a little bit longer to get started perhaps, but you can draw whatever you want as long as you tell the computer exactly what you want to see. Low code builds a bridge. When successful, it is a tool that lets you get started quickly, but it produces an output that you can treat as code and you can edit it later. So ideally, you get the best of all worlds. Now, besides saving time and letting people express themselves however they like, there's another reason for me why low code is important. And that's because it enables more people to participate in the data analysis and exploration process. There's a saying in the open source software community, given enough eyeballs, all bugs are shallow. So I think that when more people are able to put their eyes on the data, it creates an opportunity to catch issues that you wouldn't catch if not everybody were able to do that. So that's the animation. So if we come back to the core question, for me, the promise of code in any amount is having a way to tell a computer exactly what you mean. If you start with full code, you get full freedom at the expense of having to spend more time. If you're working with low code, you have an opportunity to work with a tool that is fast, flexible, and doesn't require you to remember as much syntax. But it doesn't put a ceiling on what can be done if you graduate to having custom needs later on. Rather than offer a strict definition of what I mean by low code, I intend to try and show rather than tell. I split this into 4 parts. I think you need a backbone tool to organize your analysis. You need some kind of core building block for your core data graphics. I use a different set of tools for things which don't fit as well into the grammars of graphics that I've been working with. And I think it's useful to have a way to slice and clean your data with some visual assistance. So as we go through these tools, these are the 3 questions I asked myself for each one. On the clicking side, the strength for me is that it's quick to start and quick to tweak things, but it doesn't restrict you when you have custom needs for the coding part. And lastly, I limited our selection today to tools that are free and open source to try and make what I'm showing as accessible as possible to everyone, whether you're a student or working professionally. So we'll begin with the first idea of having a way to track your data journey. I start here because going into low code means you may have to switch between multiple apps. I don't believe in a one-size-fits-all approach. A multi-tool may have a knife and scissors, but they're not replacement for a more dedicated tool. You're not going to use a multi-tool to give somebody a haircut. You're not going to use your multi-tool to cut down a tree. There's specialized things for that. So I feel that way when you go into the low-code ecosystem as well. So the first of these glues is a tree diagram. So this specific kind is called a value driver tree. It was popularized by DuPont in the 1920s. And roughly the idea is that you take a large problem and you break it into smaller pieces, and you just keep asking why at each node, and your tree will get bigger and bigger. I use the tree loosely. It's okay for your nodes to have multiple parents if necessary, because sometimes a leaf node in your tree may affect multiple downstream items. Bringing this back to DataViz, once you have this tree backbone in place, you can layer visualizations on top of it. So I like this paper from Tom Horick in 2017, where he used value driver trees to compare simulations, so models versus actual data. So here we have, for example, a graph of some expenses, and he broke it down into travel costs versus labor costs. And then within each one of these, you can break it down into management versus R&D and go all the way down. So roughly what I'm suggesting is when I make graphs, I try and organize them along a tree to see how the design evolved over time. Another type of tree involves taking one slice of data and faceting or splitting it into different subgroups. And I'm going to show you a tool that I use to make this particular example. This one is from Doris Lee's paper about drill down related fallacies. So this tool I'm about to share is made with something called Excalidraw. Excalidraw is a free whiteboarding tool that you can use. And the first thing that I'll call out is that it doesn't have any borders. You can just keep adding blocks as far as you would like and not worry about running into the edge of your slideshow maker. Another feature is that you'll notice that everything looks kind of sketchy, like if you had drawn it with a pencil. And for me, that is important because it stops people from overthinking details that aren't important yet. And so people are thinking about your project at the right level of abstraction. Before I show into some of the scripting capabilities of Excalidraw, I'll show one way in which Excalidraw fits into some of the coding related workflows that I do. So if you have an Excalidraw file, it's represented as JSON in the backend. And so what that means is that if you take this JSON and you store it in GitHub, if you go into any GitHub repo and press period, it switches you into a in-app browser where you can work with this Excalidraw file as if it were on Excalidraw, the website, which is the usual place where you would use it. And so if you're in your now GitHub Excalidraw world, you can take a diagram and you can go and edit some text or change the color to something or add some new blocks. When you're done, you can hit save, and the changes that you've made to this diagram are reflected inside a pull request. And so your team can review it in the same way as if they were working with code. But you didn't need to learn about JSON or any of the specifics of how the data is being stored. You can store it right alongside your code. So it's very convenient to have a diagramming tool where you can store your data and not worry about having to put it in the cloud somewhere. One other nice thing about Excalidraw for the coders in the audience is that you can write your own scripts to rearrange things that you've placed into your Excalidraw canvas. So here I used Excalidraw to help me debug a rectangle packing algorithm that we were developing. And you could imagine similar things being applied to rearranging blocks into a tree shape or other sorts of layouts that you might be developing in your data visualization work. There are also ways that don't require writing your own JavaScript to do this inside the note-taking tool Obsidian. I really recommend the Obsidian Excalidraw integration for that. Okay, so one last thing that I meant to show is to connect the dots with DataViz, is that you can make small graphs. So I'm going to take the poll results that we had earlier. I'm going to say code click 60 clicking, 26 coding, and 14 both. I'm going to take this text, I'm going to copy it, I'm going to paste it, and now I have a little sketchy graph that I can take and fiddle around with without needing to break my flow and go into a separate data visualization tool. So it's nice to be able to do these one-off sketchy graphs in Excalidraw as well. Okay. Well, all right. So coming back to the DataViz part. So the sketchy graph is cute, but there are only 2 chart types. You may be thinking I could do that with an expo marker, and pasting screenshots from your main DataViz tool that could get old quickly. So I want to introduce you to one other tool that I like to use. It's called FigJam. You can think of it as a collaborative design tool like Photoshop or Illustrator crossed with Google Docs. And it's inspired by the idea, what if we could make graphs directly inside of an infinite canvas? So I'm going to take you through a quick demo of what that might look like, and I'll try and zoom in extra. So here I started with a scatter plot, and we'll go into the specifics of how this graph is encoded later on. But I might say, all right, all my data is bunched up. I should change the axes so that the points are more evenly distributed. So I've rearranged my axes by removing 0 as the baseline, which is hopefully okay here since I'm not using a bar encoding. And from here, I then had a choice. I could take a break and start looking at some different themes that I might use for my scatter plot. Or I might say, well, maybe a scatter plot is not the right encoding because there's a lot of overplotting. I switch to a heat map. And each time as I'm going along and making a change to my chart, I am conscious of whether I am driving my analysis further down or if I want to loop back and try some variations. And along the way, I'm able to make comments and my teammates can comment on things. So I like using this to explain anytime I have a workflow that is not linear to kind of depict how a graph is unfolding or evolving over time. We'll see more examples of this later, but this is just a quick intro to motivate the idea of what it might look like to take the whiteboard idea and cross it with a dedicated data visualization tool. And so I made this as a plugin and you can use it for free inside of Figma or FigJam, and as of 2 weeks ago, Figma as well. So to recap this whiteboard section, I think it qualifies as a clicking tool because for the most part, we didn't have to write any code. But if you did want to eject and take your results and version them, you can do that, or you can use coding tools inside of the whiteboard. And both of these tools are free to use. One of them is open source, so if there are developers on your team, they can customize them further if needed. So moving on to the next section, which we saw a preview of inside of the FigJam widget, we're going to take a look at one of my favorite building blocks, the Vega Lite visualization grammar. So Vega Lite is a grammar of graphics. It uses the same mental model that underpins Tableau, D3, ggplot, and other tools in the modern data visualization landscape. It can be used for both interactive and static graphs, and it's built on a very long line of applied visualization research. We won't have time today to go through the details of Vega, but I think the high-level takeaway is that I think of it as a sequel for visualization, meaning it's a structured language where if you learn to write it in one environment, you can use it in many other environments. In fact, we use it for some widget types that are in development at Datadog. Philip Katz gave a talk 4 years ago at this meetup about how Straight Easy was able to have its front-end teams reuse graphs from data scientists because they just passed the Vega Lite format between each other. We do have time for one Vega Lite idea, and that is the idea of layering. Vega Lite and Onions and Shrek all have something in common. They all like layers. And layers are a metaphor that will show up everywhere from Photoshop to GIS, geographic spatial systems, where you can combine like population and housing data and different satellite images by stacking layers all on top of each other. You can think of decomposing a color picture into different layers. The semiotic data visualization library that I like has this nice diagram where they've broken graphs into like an annotation layer and a background layer and a foreground layer. Susie Liu made this graphic, and I think it actually is really nice for all kinds of graphical grammars. We'll focus mostly on the position and color encodings in this talk. An encoding here just refers to associating a field of your data set with some kind of visual variable. But there are many more of them, and we're just limiting ourselves to save time today. The Vega Lite feature that I would like to combine with the low-code world today is the power to facet. You can think of faceting as taking your layers and putting them side by side instead of on top of each other. It's very powerful for medium-sized data sets and lends itself very well to getting feedback as you're faceting about what the different pieces are actually looking like. And the tool that we'll use for this is called Sandance. So Sandance comes out of Microsoft Research. The visual metaphor is simple but powerful. Every row of data is one grain of sand, and that grain of sand can dance around. So let's see what that looks like. I will be conscious of the potential graininess and try to zoom more. But here we have something which I'm going to tell you is Brooklyn, but because of some misgeocoded data, we can't really tell. So I'm going to use faceting to focus our data. So I'm going to go to the facet operator. I'm going to go to longitude, and I'm going to say, all right, let's focus on these two sections, and we're going to skip anything else that may be skewing our axes. So I'm isolated, and I'm going to remove my facet and see whether we're looking a little bit more Brooklyn-like. So we're getting there, but there's some points hanging out here which are probably not in Brooklyn. So I'm going to go to facet by again, and this time I'm going to split by latitude. And instead of using isolate this time, I'm going to exclude, and we will now have a nicer cluster. Let me finish the exclusion, and I'm going to remove the facet, and now we have something that is maybe a little bit more familiar. Next thing I can do is try and do something with a categorical variable. So it picked something to color by default, but I'm going to change this to a category, and I'm going to go with industry. And that's nice, but once again, we're suffering from overplotting. If I wanted to spot trends in where the garages are, it's hard to tell because things are covering each other up. So I'm going to facet by industry instead of just encoding it with color. Sorry, go. So now I've taken the same plot and I've split things up by industry. And so that you can maybe read some of them, I'm going to focus on two more. Pick three so we can look at them side by side. And notice that I don't have anything insightful to say about these particular groups. So I'm going to say, all right, this was a bad choice. And I'm going to use the history, and then I can undo what I just did. And in fact, every action that I was applying in this low code tool is recorded here. You can step forward and back if you messed up and focus on the subsets of data that you're interested in. So at this point, you'll be maybe wondering, all right, this may be a nice faceting experience, but what does this have to do with Vega? Well, all of this is enabled by the fact that every action that you take is modifying a Vega definition. So if you go into the cog menu and you click show Vega spec, you now have a big JSON file that you can take and paste into the Vega editor. And I'm going to pass on it today for time, but I have a worked-through example of this that I'll share later, where you can see that all the actions that you take inside of the Sandance UI can in fact be captured in a Vega spec, and then you can fiddle with it later and do things that are not permitted inside the Sandance UI, such as making custom Vega expressions if you have that need. And I have one worked out example that you can see in my slide to prepare for this possibility, where you can make a tree map and then export it to Vega and then put it into FigJam. And so have this end-to-end experience. Cool. So one last thing before we move on to the next section, I want to talk about the data half of the word data visualization. And we're going to look at another New York City open data set thing for this. So New York City has a real-time air quality monitoring service where, well, when I put this together, there were 5 sensors. 4 of them are being maintained or updated, but at one point there were 4 lines here. And I wanted to bin this by 1-week intervals instead of working with 1-day intervals. So I went to the data dictionary and saw that this data is actually available on GitHub. And one neat thing that I learned while doing this is that if you find a CSV on GitHub, if you go ahead and type the word flat in front of the word GitHub, GitHub has a low-code data visualization explorer built right in. So you can do basic filtering operations. You have a little scrubbable histogram UI where you can focus on points that fall within a specific range. Amelia Wattenberger's team works on this at GitHub. Anyways, I digress. You may notice that the data stored in GitHub is in a wide format, which is very nice for humans. We can take a look at it. But for those of you that are familiar with the tidyverse, you may notice that this means that you will probably have to change your code every time a new sensor is added or removed or theoretically taken down for maintenance. And you have to take, and you may have this desire to take these columns that we're seeing here and to rotate your graph into long format. And so your data ends up being taller, but it ends up being nicer for many Grammar's graphics libraries because you don't have to have your data schema changing all the time. So in the original version of this plot that had to work with this wide data, and I'm just going to assume that you probably cannot see them at the same time. But in the original version, the developers had to create a new layer for every single column. And every time a new sensor was added or removed, you had to write something that sort of resembled this new block of JSON and add a new color every time a new sensor was added. But thanks to Vega's flexibility, it turns out that this is not in fact required. Vega has this idea of a transform operator, which will let you transform your data from wide to long format without needing to go out into a separate coding tool. So, oh, actually it is loading. Well, I think it's faster in the other spot, so I'll go back. I'm able to, in one spot, just control all of the columns that will need to be folded to go from wide to long format. And with that, I no longer have to add multiple layers each time that I want to add more series to my graph. I can just modify this one section of the Vega array, and then the one layer that I made before, which says just change the color based on the location field, that's able to respond to all the series that have been added or removed. Yep, so I know this part was quick, but this is just to motivate the idea that I think a good grammar doesn't include just the coding part, but it also gives you some primitives that let you rearrange the data as needed without needing to jump to a separate environment. And there's many other transforms. I talked about one, but there's 18 others. So Vega Lite, I didn't really think of it as a low-code tool until maybe about a year ago. But I've realized that because it belongs to an ecosystem, there are many tools that let you generate Vega without writing JSON by hand. But if you run into limitations with any of these tools, you're always free to hit eject and say, show me this in Vega or Vega Lite, and then you can take it further. And most of the Vega Lite offerings that I know of are free and open source. I'm active on the GitHub Vega Lite organization and would love to see you around if you're looking for an open source project to contribute to. So Vega is powerful, but I think that there are limits. Just because you've put latitude and longitude on a scatter plot and put a picture in the background doesn't mean you have a useful map. Complex structures require interactions and camera controls that you can make maps with Vega Lite, but I like to supplement it with some other tools. And so the first of these that I'll share is called Kepler. Kepler is an open source tool. It has plugins in Jupyter and Tableau and Visual Studio Code. I'll show you a demo using the same Brooklyn Businesses dataset that we were just looking at inside of Sandance. So to get started with this, what I did was I had a CSV file and I imported it. I haven't done anything else yet. Similar to Vega, so once I have some points, I can go and choose my encoding. So it defaulted to points, but as is a trend today, there's opportunities for overplotting. I can quickly change the encoding method to hex bins, and there's 12 other choices. I'll just leave it at points to simplify. Just to give you a sense of what are the things that I think are trickier to do without using a framework like this, you're able to change which fields are showing up inside your tooltip. So based on the feedback from earlier, you may not be able to see this, but what I've done is I've just added the industry and the actual name of the business to the tooltip. So you can browse that. Another feature that comes from interactivity is that you can put a geocoder. So let's say for those who are not familiar with the area and are told that there's a place called Dumbo in Brooklyn and you want to spot it, I've typed Dumbo into the geocoder. It's done a lookup using Mapbox, and it has placed a point on my map so I can focus on a region of the graph that relates to a point of interest that somebody has told me is significant without needing to go to a separate tool. And then many of the things that you could have done in Sandance, like take the points and color them by industry, you can also do that by going to your encoding definition, going to the color world, and doing some work with the color map. So I'm actually going to step through this example because I think they have a nice color picker UI for this. So if I wanted to color by industry, first I click industry, then I'll say, well, I knew from earlier that there are 20 items, so 6 is not enough bins. So I'm going to change from a sequential color palette to a qualitative palette, and I'm going to change the number of ramps to 20. And now I'm not going to repeat colors as often. And then now I can see something similar to what we had in Sandance earlier, except for with a base map applied. One last feature of Kepler that I would like to call out is it has really nice support if your data set has some sort of time field in it. So what I have here are licenses, and each license was created on a certain day. So I'm going to click Add Filter. I'm going to click Creation Date, and I'm going to take this playback window. And now I can either manually scrub on the mini map to focus on businesses that were created at a certain time, or I can animate this filter. So I can watch for trends in when businesses of a certain industry or by some sort of categorical variable seem to be blipping in and out of my map. And I'm not really sure how you would do this quickly in another tool. So this is a really convenient thing to have inside of the Kepler world. I'm going to pause there. If you build up a configuration that you think is really good and you want to do something programmatic to your Kepler world, you can click Export. You can click Export Map, and then you will get a JSON file which includes all of the settings that you configured manually in your GUI. And then you can take this configuration and paste it into Kepler running inside of a Jupyter notebook or whatever place you like to write Python. And so after this, I'll share a link to a binder deployment where you can use Jupyter without installing anything and try for yourself how you can take a configuration that started inside a Kepler map. And in this case, all right, let me work through you won't be able to read it, but what I've done is filter to just the businesses that seem to relate to fruit. And I did the filtering with Python code instead of waiting for it to happen inside of Kepler. And then the number of points should have gone down. And if not, I will blame the live demo effect. But we'll move forward from here. Cool. So the second tool that I want to touch on for this section is the ability to make trees. There is a tree graphing primitive inside of Vega rather than Vega Lite, but I like raw graphs. It's an open source project that lets you create a GUI for all kinds of not super conventional graph types. So I'll take us through a small example. There are 29 different templates in the raw graph gallery. Trees are just a subset of them, but yeah, we're going to focus on a radial tree because I'm not sure how to do that in Vega Lite. So for my first cut at this, I used a not radial tree, but it doesn't fit very well into a slide. So I'm going to show a radial layout, not because I'm endorsing using a radial layout for this type of thing, but because it has a good aspect ratio for this type of thing. And sometimes you just want to have a head turning graphic. So to do this, once again, I uploaded a CSV. For each column, you can change the data type. Usually the inference is pretty good. The main change you might want to make sometimes is you have something like a zip code and you want to treat it as a string instead of a number so that the leading 0 doesn't get chopped off. Otherwise, the type inference is usually pretty good. Then you choose a template, and then you, similar to the other tools, go through this process of taking your fields and mapping them to visual variables. So in this case, I'm going to take gender. Oops, I picked the wrong template. Change the bar chart and go to radial dendrogram. Yeah, so I'm going to lead with gender. I'm going to follow with ethnicity. I'm going to put the actual name down, and I want to check how the ranking may have changed over time. I'm going to pick that as my fourth. So now we've gone 4 dimensions deep, but we're not done. We can actually have space for a 5th dimension using color. I'm going to take rank and put that on color. And lastly, I'm going to take the year and use that to label because that's the very last node in our hierarchy. So let me grab the year and I'll put that on label. So now we have the beginnings of our chart and things are a little bit clumped. So I'm going to start by growing the diagram a little bit so that we have a little bit of breathing space. I'm going to note that the circles are overlapping a little bit. It would also be nice to have a legend, so I'll add that. So now I go to my chart and I'll say, all right, let me dial the diameter back so that my circles don't overlap with each other. It's a little bit better. And then lastly, so the colors, technically that is a number, but I'm actually okay here using a categorical encoding, so it'll be easier to see what the places are. So I'm going to change the encoding to ordinal and use a different color scheme. If I wanted to customize each hex code, I can actually change that inline. That was not a good choice. The spacing isn't very good, but that's okay. And then you can change other settings related to the labels. So I'm going to reduce the weight of the labels and then say, all right, I'm good to go. So now that you're here, you have an SVG, which you can go and edit in Illustrator or Figma. Or if you choose the raw graphs format, you'll get a JSON file which encodes all of the actions that you've been clicking around inside this customization section. So it may not be Vega, but it's something close to a grammar, not a grammar, but a machine readable configuration which you can store in GitHub and version. And say you have your own color ramps and you want to use that instead of the ones that are built into raw graphs. You can do that by taking the JSON in the raw graphs and changing that in your preferred programming environment. So go back to the slides. I didn't work through an example for this part, but I just want to note that if you or your organization has some kind of custom JavaScript chart and you want to have a GUI that looks like raw graphs, you can do that using the raw graphs template. You can self-host the raw graphs app, and you can make a set of options that will let you reuse your custom JavaScript chart, but people will be able to configure it using something like the raw graphs GUI instead of needing to edit inside a code editor. So I think it's really wonderful that the raw graphs project open sourced this and made this available to help people make their graphs more reusable. So to recap the section, once again, both of these tools were primarily clicking based, but They also offer a way to eject and have a machine readable format that you can version and edit and then import back into the GUI-based tool if you have custom needs. And they're both free and open source. So everyone can try them out. All right, so we're on to our last section, everybody's favorite topic, slicing and cleaning data. I have a confession to make. While I do write Python data cleaning code sometimes, I still use a spreadsheet many, many times because it's easier to browse. Clicking is faster than typing for many common operations like dropping columns or just hitting Control F to find some columns. And I get visual feedback right away about whether my scripts make sense. But the usual hurdles I run into is when I need to make a custom column or write a regular expression. And at those times, I wish I could write Python inside of Excel. So that's roughly what you're about to see. So the first of these tools is something called Dataset. It's a tremendously flexible tool born from experiences working in newsrooms from Lawrence, Kansas to The Guardian in London. And it's led by this very generous fellow named Simon Willison. Dataset both produces SQL and it allows you to supply your own SQL. SQL is a query language that you can use in a whole bunch of different tools. And you can use it to build your own data portal. Dataset doesn't have any built-in visualization utilities. Everything comes in through a plugin. So I'm going to take you through a very, very short demo of Dataset. So this is from the Dataset website. There's a big table down here, very similar to the CSV that you would have seen if it were just a CSV stored on GitHub. But because it's its own app, you have this ability to facet. And what that means is that if there is a column which has a lot of categories in it, you can go and say, all right, I want to focus on this particular category, this particular owner, and it will filter the data set for you and generate this big SQL expression so that if you need to derive a custom column, if you need to do some rounding, you can do that without needing to have some SQL familiarity from the past. You may have noticed this mapping plugin. So if you have some columns that are named latitude and longitude, Dataset will automatically just make a map for you. And this came in handy when I was cleaning some of the data for the previous demo. So this is the Brooklyn data that we were seeing before. And you may notice that Brooklyn is over here. And there's this big cluster of points out here in Pennsylvania, in Shippensburg, which is decidedly not Brooklyn. Now, I don't know why these points are coded this way, but if the geocoding is off, there might be something else about these points that are off. So this gave me a hint to say, hey, maybe I should either reach out to the data source or I should just filter out these points and focus on everything inside my Brooklyn bounding box. So Dataset is nice to do this sort of basic geospatial quality check, even without needing to write any custom scripting. There's one other Dataset plugin that I would like to share with you. It's something that I worked on, which is ported over from the world of Interact. Interact is a variant of the Jupyter Notebook, which people can install just by installing an app and double-clicking on an icon, rather than needing to know about installing different Python environments. And a common problem in the Jupyter and Pandas data exploration world is that you have a new data set and you theoretically could start filtering it, but you're not sure what filters to be applying. And so wouldn't it be nice if you could have some automatic exploratory visualizations that are available where you can click around before you need to start writing some heavyweight matplotlib or Altair code. So yeah, and I worked on this with Elijah Meeks and some other folks in the Interact ecosystem. So this data set is the Happy Planet Index. Every country is represented, or not every, many countries are represented. And the first view is just a basic table, but you are able to, at a click, make a whole bunch of exploratory graphs. I'm going to focus on the scatter plot view, but I just want to note that if your data set had a hierarchy in it, there is technically a built-in a dendrogram explorer. You can change it into a tree map or other hierarchical visualizations. It's built on top of the semiotic framework that we saw earlier in the presentation. But I'm going to focus on the scatter plot because that's what I end up using the most. So if you look at the encoding choices, the choices have been restricted to what kinds of columns actually make sense for that particular menu. So if we have something like a category, like color, only the string columns have been selected, whereas the numerical columns have been routed into the X and Y encodings because those are suitable for assigning to the X and Y axes. So yeah, the ID is not really a useful column. So I'm going to change, so do life expectancy, well-being, and you can make your own little Hans Rosling animated dance of the countries if you would like. I'm going to size by GDP. And then you can do some things that I haven't seen elsewhere, like throw in some marginal graphics, which will throw a 1D distribution or like a rug plot on the side of your graph. And hopefully what all of this does is help you to figure out what are the numerical filters that you should be applying once you need to explore this data more programmatically later on. So I'll move on from this part of the demo, but once again, say that this is a plugin that you can use for free when you're using Dataset, and I'll link to documentation at the end. So I've hinted at this spreadsheet Python relationship a couple times, and now I'm going to share with you a tool that I found last year that helps with this. It's called Meetup. And the best way to summarize this is that it's an Excel-like experience where every time you click on something, some Python code is generated, which will allow you to repeat this analysis the next time you get a similar looking data set. So we go back to our friend Jupyter, and we're going to go through a power plant data set. So you can take columns and you can delete them. Say a common transformation when you decide that something isn't going to be useful for you. And we can see that each one of these actions resulted in some data dropping code. You could derive a new column. So for example, if I were to take the capacity and I had something to divide it by, I could click add column and I could say, let me take this column and divide it by say 2 or something. And then now I have a derived column generated in my Python code. You also get some nice summary statistics. If I click the filter item, you get counts for all of the categories. And if you have a number, you'll get a histogram showing the frequencies for all of the items. Because we had the AV issues earlier, I think I'm going to cut this demo short, but I'll try and record a short tutorial of what I would have done here and include that in the Meetup notes afterwards. Also, for those of you who want to use pivot tables but can't remember the pivot table syntax in pandas, that is me. You can do things like group by using the pivot operator. That's something I really like to do inside of Meetup sheets. Cool. So the last piece from this section to motivate why we're doing this cleaning, I think some of the really exciting low code work is in the space of chart recommendation, but some of the recommenders really do not work if you try and use them with a data set which is too big to run in the browser. So I cleaned up a restaurant inspection data set using Meetup sheets for this demo. I just want to show you what are some of the possibilities when you have a system that's able to do graph recommendation inside of the browser. This one is called Voyager, and there was quite a big team actually that worked on making this. So I have a spreadsheet. I'm going to import it. Go through my script. And let me zoom out because I can't see all the pieces. So I've just loaded the data set, and already I'm given distributions of a bunch of the different columns. And I can pick what I think would be an interesting starting point. So I decided I'm going to start with the counts of cuisines. So here I have my starting graph, and now I don't really know what column I might use to split by next. So I can just kind of visually browse and think which of these things is maybe standing out to me. And I'm going to say that maybe action is interesting to me. So I'll click it. And I can keep doing this. The last one that I'll try is to do a small multiple using the scores. And once you're done, you can take this, you can hit bookmark, and it will convert, just like all the other tools, your actions into a Vega Lite specification. You can take all this, paste it into the Vega Lite editor, and you'll be able to change your colors or do other custom Vega Lite things to this spec that started inside your visualization recommendation system. So I promised you that I would tie all these pieces together at the very end. And I'm going to do that by showing you what an actual data exploration journey looked like for me when I was preparing one of these demos. So I started with a data set from the New York City Open Data Portal. I made some notes inside Excalidraw. I made notes of what I was doing. I made notes each time I did a data cleaning step or reached out to the provider of the data set and asked, what does this column mean? And then I exploded my work into a tree structure. So I started by taking a look at the distribution of the expiration dates. And I noticed that very few licenses were being registered on Friday and Saturday. So I wanted to understand the nature of this trend deeper and see if maybe it might vary by industry. So I split out into a branch and asked, does this generalize? And I made a bunch of different exploratory plots. And for each one of these plots, I didn't need to go into a separate tool and make a screenshot. I was able to click edit. A little Vega Lite modal would pop up, and then I would edit a field inside the pop-up. I'm not sure why it's, and then be able to make variations on my graph very quickly. So at the end, I ended up with some small multiples, and I decided that it looked like that there was something special happening on Monday, but really it was dominated by home improvement contractors. Like it just skews the whole y-axis. And that was what was making the Mondays really jump out. So I explored a couple different other branches that we won't go into right now, but I just wanted to call out that I was also able to take my screenshots from Sandance and include them, my screenshots from Kepler and include those. And I took my screenshot from, thank you for bearing with the zooming, from Voyager, and document the process for what was going on there as well. So all these pieces from these 10 different tools that you've seen, they all come together inside the mega map that is my FigJam analysis board. Cool, so let me bring us back to our slides. So whether it's dataset or Mito or something else, I think data cleaning is a lot easier when you can see the rows as you're cleaning them. You'll have a much easier time reusing the analysis if the tool has some kind of escape hatch, because then your analysis can be repeatable. And all these things have a free tier, but there's also a commercial tier with more support if you happen to need it. So just to recap, I think that no matter what tools you're using for your core visualization, having a way to make a tree of your analysis will help other people follow the trail of what you've been doing as you jump from tool to tool. I think that having some kind of grammar of graphics, whether it's Vega Lite or something else, is very good to have as a foundational building block. And whatever it is, it's going to be easier for many people in your team to work with it if you have a choice between either writing JSON or generating it by clicking inside of a GUI. It's okay to use dedicated tools for things like maps and hierarchies that have a high interactive demand, because so far I don't find that those fit as well into a standard grammar of graphics. And lastly, it's just so much nicer to be cleaning your data when you have a way to make it visual and a way to script the work that you've been doing. I made a list of, I can't believe it, 10 different ways that we've looked at in this pretty short period of time. We went through FigJam and Excalidraw. You can use a grammar, you can use Kepler and raw graphs for your maps, and dataset and Mito sheets for your actual data cleaning. I showed you 10 different tools, but I just want to take a moment to highlight that while tools are part of the bridge, the reason why we're trying to bridge a gap is to help people to notice things. So my hope for today is that you will take at least one of these tools to try it and then show it to somebody. I'd also like to leave you with a quote that inspires me as a tool maker, attributed to Marshall McLuhan. First, we shape our tools, and then our tools shape us. What do I mean by this? My first hope for this talk is that it helps you do the things you've already been doing before, except faster. My second hope is that this talk will spark conversations that expand the field's concept of what is possible as our tools shape us. So thank you for your attention and bearing with the AV situation. And I'm very happy to take any questions you may have now or via email or Twitter in the future. Thank you.
Cameron, that was fantastic.
Thank you, Randy.
And I was going to ask, how do you want people to reach out to you if they do have a question later? You put Twitter up here. Is that the best way to do it?
I think I think that makes sense for now. But also, if you want to send me an email, it's my first.last name at datadoghq.com. I'm just not typing it to give the spam bots a harder time.
I understand that. Let me change to that and go back to us. Okay, so I got a handful of questions for you. And if anybody else wants to add a question while we're talking, go ahead and drop it into the Q&A. But I do have a handful, especially since I don't use most of these tools. I'm sort of asking you as somebody who's seeing some of these for the first time. Lo posted a question in the Q&A, and she said, I'll read it so everybody understands the question, that this is really helpful. I'm just learning Python. I only work with small, medium data sets, and I love the flexibility of Python, but I'm so slow. Seems like these tools are maybe a better balance. Advice Vega looks amazing, but also very shiny. That was sort of the question.
Yeah, I'm opening it to see if I can parse it. So I think if I can frame this question a little bit differently, or yeah, let me know if I miss it. I think one thing somebody might wonder is, like, if you have time to spend time learning more at something, would you spend more time with the clicking tool, or would you spend more time learning the core visualization framework? I think that it's not necessary to choose just one. It's very much makes sense to spend time in both places. With that said, I think that depending on the schedule in your environment, it's usually easier to get started in a clicking-based tool just to get a sense of, in a very flexible grammar like VegaLite, what is possible. And then when you run into something where you're like, I wish I could do this, but there's no menu for it, then you hit eject, and then you learn the way to customize the number formatter or use the color scale that is not in the UI, or whatever custom visualization need is there. I've been using VegaLite for maybe since 2018, and there are still parts of the API that I am not familiar with, and that I go back to the docs every time to learn it. So it's one of those, like, maybe quick to pick up, but maybe lifetime to master things. And I think that that's very much okay.
Yeah, that's true. And she just commented in the chat window too that you nailed it. That's what she was looking for.
Wonderful. Thank you. Thank you for the question.
I know because of some of the other issues, will your slides be available, especially so people can get back to the list of all 10 tools and stuff like that? Are we going to put a link in the Meetup comments or the whatever?
Yep, they will be posted later.
Okay. Do you use all these tools? I know you're aware of all 10, or do you have a couple that are your go-to tools?
All of the ones that I mentioned were things that I used in the past year for actual things. I had to cut things. The one that I'll admit that the thing that I end up using the least is the stuff around visualization recommendation, because it has to run entirely in the browser. And usually when I'm working with a data set, I have some sense of which things that I want to pay attention to. I think that's probably the area that I think that there's the most room for improvement, but it's also an area of very active visualization research. So yeah, I use all of them, but I probably use the visualization recommendation the least.
Okay. What do you think? And because if it's like me, like people haven't touched some of these, like what would be the learning curve for one of these tools? Like what kind of investment should somebody expect to figure out Vega Lite or a Kepler or something like that?
So one secondary consideration for the ones that I picked is how much online video content there is for them. I would say for something like raw graphs, let me step back, because I like using Tableau, but I felt that Tableau had a learning curve. I think that if you have the mental model for a grammar of graphics and layering and what it means to have encodings, everything that I showed should be something you can be productive with within a day. If you are learning about visualization and the tool at the same time, I actually don't think it matters that much which of these tools that you pick, but that you get familiar with the core like grammar of graphics idea. But outside of that, I think that they're all within a day of reasonable productivity.
Wow. That's a lot shorter than I would have expected.
I'll also say that I picked in my demos sort of shiny examples for things that maybe it would be a slightly longer window, but for like the things that you might go into the tool saying like, I want to do the thing that I did before, except for inside of here, those should be pretty approachable.
Okay. I'm going to jump to, we got a new question in the Q&A, and I wrote a related question. So I'm going to put two questions and let you sort of combine them into one. So Lamel asks, any thoughts on security when using these browser-based tools? Are you actually using these for Datadog work? And so that was sort of my question is, especially for open source tools that are browser-based, if you're working with confidential proprietary information, there's a lot of restrictions on, you're not allowed to, upload that to a tool. You want to have an on-premise kind of downloaded desktop tool.
Yep, that's a great point. So all of the, with the exception of Figma and FigJam, everything else that was shown running in the browser is something that I could run either locally on just my laptop, or an infrastructure admin could run something in your company's intranet and then make it work with proprietary things without an issue. Some of the tools have some kind of telemetry in them, which is sending analytics to somewhere. So Kepler, you should be aware, sends Google Analytics back to the Kepler team. And Mito also has some telemetry. But I think that, data ownership and privacy is important. And so if you are working with restricted data sets, it will be important to run it on just your laptop or inside your corporate intranet. So data set, everything that I showed inside of Jupyter, all of those you can run locally.
Okay, good. I mean, it is tool dependent. Each tool is going to act on that differently. So I know things like Flourish that just got acquired by Canva, that's different. That's an upload, that's not a local based rendering, that kind of thing.
Yeah.
Okay. So here's a long one. So read along with me, but I'll read it out so that everybody can hear it. So Samuel asks, hello, really enjoyed the presentation. I'm a software engineering student currently finishing up a year-long boot camp for my second capstone. I built a Flask React app that analyzes lyrical data for a given artist and generates visual representations of unique words, word frequency, and polarity. Going forward, I'd like to transform this project into some sort of simple GUI. I understand that it probably won't be possible for my first job, but would like to know what are some things I could do to leverage my projects and passion for data representation to land a software engineering job related to data visualization somewhere down the line. So building a data visualization portfolio and, showing off your work.
Yeah, so hi, Samuel. Thank you for the question. I think what is important for somebody who is interested in working in data visualization tools and making software potentially is to do things like what it sounds like you did, where you really work end to end, all the way from data collection to cleaning the data to providing things through the back end to figuring out how to represent it on the front end. Depending on what type of role you're going for, you might end up in a situation where there's a whole team dedicated to doing just one of those parts. And they may not actually be looking for somebody to do all of those pieces. But I have found that having exposure to what can happen to your data at any stage of the pipeline is very valuable for being able to suggest alternatives or propose interactions that other people may not have thought of if they're only thinking about one layer of the stack. Before I joined Datadog's front-end team, was working as a data engineer, thinking entirely about data cleaning and pipelining. And I think that it has helped me a lot in my current role, where I'm able to lean on other teams when we're working with experienced or existing data sets. But when a new data set is spun up and there's not a whole team for it yet, I'm able to contribute to other parts of the process. So I think that if you have your project, really experiencing different parts of it is valuable. And then when you're talking to people about it, just mentioning that you're not concerned about focusing on just one part of the stack, but you're really thinking about the data holistically. And I think that resonates with people who are looking to build open-ended data visualization applications. Hopefully that gives you some ideas, and you can reach out afterwards too.
I don't think that the data itself matters. So like this song lyric data is perfectly acceptable as a portfolio demonstration of what someone can do. And so I think that's really, showing off what you can do. And then what you're talking about is sort of a behind the scenes, like what did it take for you to get there, would be something else to also show off, which is you did the data cleaning and, what are the options you tried before you got to the end result, and that type of thing.
Yeah, I think that this is a great project, and you'll experience some messiness working with, natural language. So yeah, it's a good project.
Okay. In some of your tools, I noticed you were using screenshots as your output. Do they generally have a way to output into formats that you could, the final graphic output to put into a report or into a presentation, or to put, a JPEG onto a website, that you want to use as a background image? Are there output methods for most of these tools, or do you end up taking screenshots?
Yes. So for two of the tools, specifically Kepler and Sandance, because those things have a 3D component, they're not producing a format that would work well inside like an Illustrator or like a vector-based editing tool. But everything else, everything that was purely Vega Lite based and 2D, they all offer multiple like PNG or JPEG formats for traditional raster graphics, but they also offer an SVG editable vector format, so you can have crispness at whatever level of zoom. I figured that was what you're going for. Yep.
Yeah, vector, great. That's even better. But even if someone's just going to try and drop it into a presentation or something, but if I can get a vector file, then I can edit it and do whatever I want with it, resize it and recolor it, or even add it to an infographic or a report or a presentation or whatever I want to do with it.
Yep. If I understand correctly, it's a pretty common, or not common, but I have a couple of friends in data journalism who use raw graphs, start there, and then they send the graphic to Illustrator to do the annotations. But this way, it all looks like it came from the same place.
I know there were a couple areas that you didn't have time to include. I'll ask, like, where did you start? Like, which one did you start with?
So actually, the place that I started, I left off because it's technically I figured many people may have used it already, but I started with Tableau, specifically Tableau Public. And I was really worried about the learning curve. I watched a bunch of YouTube videos. I borrowed a book, but I really liked how it didn't have a pre-configured set of chart types. And it got me into this world of thinking about taking field names and mapping them to visual variables. And probably as I'm using all of the other tools that I showed, the mental model that came from Tableau is influencing my ability to navigate through it. Like I assume that if a menu item exists in Tableau, like the ability to change the column type inside the pill, this other tool could theoretically have it as well. So I should give a shout out to Tableau. It's not, the professional version is not free, but if you're using with public data sets, people can use it for free.
Right. I mean, that goes back to the earlier security question, because Tableau Public wants to upload everything to the server, but Tableau Public gives you the full functionality of Tableau.
Yep, that's right.
But okay, so that's how you started. Today, would you recommend something similar, or would you recommend they start with a tool or dive into some learning a little bit of code in Python or something like that? Where would you start someone today?
So if I were to start right now, probably as shown by the number of examples that reference it, I'm really bullish on the Vega Lite ecosystem. I am rooting for the existence of a tool which is like Tableau, except for it produces Vega Lite on the other side. Voyager is approaching there, but it has some other things in it as well. And it's not commercially backed. It's a research project, so you can't, it's not as actively developed. I think that if I were to, on the coding side, I would be encouraging people to use something like Altair, so that you can build up your grammar of graphics stuff programmatically, and then to use any number of the GUI-based tools for Vega Lite that were shown elsewhere in the presentation, to kind of help the process of learning about what is possible. Yeah, so Vega Lite ecosystem, I think, would be my main recommendation.
I know that's your hope, is that something would be Tableau-like and output Vega Lite, but do you think that's where the industry is going? Where do you think these low-code tools are going?
I think once more places are using this common format, you separate the responsibilities of producing a chart description from actually taking a description and combining it with data. So I think that there will emerge a separate class of tools to help recommend good charts. And then once you have that, you can put it into another company that actually has a data set and then use that to render it. So I think that, but it requires that different companies are using the same format to describe charts. Otherwise, you can't have this interchange. So I think the future may have a lot of interoperability in it, and it depends on people picking a format. It might be Vega, it actually could be something else, but for now, I think Vega Lite is doing pretty well. Thank you for the question.
Okay, so I think we're running at time.
I want to thank Randy once again for helping the New York chapter and hosting this. And I cannot thank Cameron enough for this excellent presentation. If you look at the chat comments, you can see how well it was received. And thank you to all of you for joining us.
Thank you for having me.